Hi parents, guardians, and students. The following tutorial video will walk you through some tips, tools, and strategies related to our data management unit. Data, or data, is another word for information. We collect data to help us find out about the world and organize and display the data so that we can look at it easily and learn more. Data is collected in order to review patterns or trends, which can help in planning. It's important to look for trends or patterns over time when looking at a graph. Can you spot a trend between these three bar graphs? What do you notice about McDonald's as compared to other restaurants over the years? We can easily see that McDonald's remains the most popular fast food brand. Often, investigations or surveys are conducted in order to collect information. That data can be quickly inputted within a tally chart and then translated into a frequency with a quick strike of a pen. Tallying is a way of adding that uses groups of 5, 5 being a very, very friendly skip counting number. Imagine investigating the most popular color of car passing your house over the course of an hour. It's easier to draw tally marks in one of 5 rows than to write red, blue, silver, red, other, black, etc. If you use a tally chart, you could note down the color of the cars as they pass by quickly making a tally mark, and then find the frequencies at the end of, let's say, a 1-hour period. I remind students that as we record tally marks, 1, 2, 3, 4, the 5th tally mark ties off the bundle or acts as a belt across the waist of those to make that nice, neat bundle of 5. If we take a look at white, we can easily skip count by 5s, 5, 10, 15, 20, and then count on 21, 22, 23, 24 to arrive at the frequency of 24. As you can see, using groups of 5 makes it easier to see the total. I have tally marks tattooed on the back of my neck. Can you figure out why? The whole point of graphing is to visually summarize our number information drawn from the tally marker frequency table. By size alone, we can easily see the most popular style of learning and the least popular style of learning within my class. We can skim across and compare the different styles as well. When designing a graph, recognize that neatness matters. We want the viewer to instantaneously be able to understand the information and then analyze it. Should you make a messy graph and fail to use a ruler, well, then that viewer might as well just simply look at your frequency table. The bottom axis is referred to as the x-axis. And the vertical is oftentimes referred to as the y-axis. I've taught students over the years a visual technique to remind them as to which axis is which. Over to the side, if I draw the letter X and place a horizontal line atop it, you'll see that the X resembles the foundational structure of a picnic table. Whereas the Y has a vertical stem to remind you that this axis that runs north and south is labeled the y-axis. Beyond neatness and the use of a ruler in creating an effective graph, Level 4 graphs ought to have specific titles with capitals that answer the questions who, what, where, and when. I've suggested to students to use the following graph title starter. This graph shows. That puts the student in a position of answering what was trying to be determined through investigation and survey, mentioning then who did, in fact, conduct the surveying, when that occurred, and where the location was. All of this information is really, really pivotal for the viewer so that they can understand the context in which it was drawn from and compare it to other places, locations, and times. I'm sure you would agree with me that a specific title assists the viewer of the graph in understanding what the visual representation of the numbers is all about. Subtitles also assist. Think of a title as a boat floating atop the surface of the water. Think of a subtitle being a submarine traveling beneath the boat or title or underwater. Subtitles help to represent what each bar, in this case, means. The x-axis subtitle traditionally expresses what was surveyed. The following subtitle sentence starters are quite useful. The y-axis subtitle typically expresses the number of blank surveyed, what was observed during the investigation. Let's say someone surveyed the favorite colors within a class. We would represent the range along the y-axis of number of people who preferred a particular color. An additional x-axis subtitle is required to represent what each bar means. It is above each one of these secondary x-axis subtitles that the bar will be drawn. Showing the number of students who preferred a particular color. Suppose one acquired the following information through a survey. One has to ensure that when making a graph, that the full range is covered. The range is the difference between the least and greatest numbers in this surveyed set. The lowest number is 1, with only one student preferring the color green, and the greatest number in the set is 6. I ask students to liken the y-axis to a thermometer. We need to make sure that the thermometer covers the full range of the set. As you can see, I've ensured that there's enough room to cover the full range for my data set, from 1 to 6. I've ensured that my y-axis goes up by even increments. In this case, each notch is an increase of 1. We want to ensure that. Otherwise, the graph could be misleading.
Okay, so we have collected our data using the tally mark sheet. Now what we need to do is use this data and put it into a bar graph. Now, how do we do the bar graph? It's very simple. So what we first need to do is have a title for the bar graph. So in this case, we are going to call it, "Which cake do we like the most?" So just like a story, we just put a name on the top. So, which cake do we like the most? Okay, now we have two lines one on the left hand side. We can use our ruler. Just go straight down. And another line this way. Going from left to right. Now these lines are both called axis. Now this axis is for numbers. So in this case we would write the number of people. Number of people. So this would signify the number of people that like which cake. And this axis down here, we would use it for the types of cake. Okay, now if we have a look at our tally mark sheet, so my one is on the computer, we need to look for the biggest number. So the biggest number is 11. So this would mean the top number would be 11. So I would start from 0 in the corner and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 on the top. Now the types of cake we have. So first is Christmas pudding. So in nice neat writing, Christmas pudding. And we put a line like that. Next cake is vanilla, butter cake, and another line through there, and chocolate mud cake. Mud cake and another line. You can use your ruler if you need to. So now what we need to do is first is the Christmas pudding. So we have 9 Christmas pudding. So what I need to do, or this is what we should have done earlier, is put a little dot just so we know where to go. Okay. So 9 people like Christmas pudding. So from here we're going to draw a line to where we think matches here and go straight down. And then we do a quick colour in, like so. Next we look at the vanilla butter cake and we see 4 people like that. So we go to number 4, draw a line and down. You can also use your ruler if you feel it's easier. We colour that in. And last we do the chocolate mud cake, and 11 people have chocolate mud cake. So from here we use a line, we go up to the top because that was our top number, up to 11 and down. And we colour in. Now if you use your activity books, they should already have lines in them, so it's a bit easier. So that is our bar graph, and that's finished. And that's quite easy. Now the reason why we do this is if someone that doesn't know what we are doing asks us which cake do we like the most, we can give them this bar graph and they can see straight away that the chocolate mud cake is the most popular cake.
First, you have to know the graphing rules. Bar graphs are used to display data with unique categories, trying to show the difference between the groups. Like with this graph, which shows survivability in zombie outbreaks. Now the rules for a line graph. Line graphs show changes in one variable, or changes over time. In a line graph, one variable has been divided up and is displayed on the x-axis. This is shown in the graph displayed, as time is the variable that is changing. Danger level goes down over time because everybody turns into zombies and there's no more danger.
There are many different types of graphs. All of them are used for different reasons, but all of them make information easier to read. A line graph is used to show how the quantity or amount of something changes over time. For example, I recorded how many apples I ate each month for 6 months. Here is my data in a tally chart. Remember, data is the information you collect in an investigation. At the end of 6 months, I can add my data to a line graph to show how the number of apples I ate changed over time. After I add labels to the side and the bottom, I can begin to plot the data. When you plot, you put the data in the right spots on the graph, like this. Plot that point, and plot that point. There. And now each point on the graph shows the number of apples I ate that month. To make it a line graph, just connect each point in order, just like a dot-to-dot picture. This makes the data even easier to read. In this line graph, it is easy to see that I ate the greatest number of apples during the 3rd month, 10 apples, and I ate the same number of apples in the next 2 months. I know this because the line doesn't go up or down, it goes straight across. And in the final month, I ate the least number of apples, only 3. Look how many more I ate in this month than I did in this month. All we need to do now is add our title, Apple Time, and done. The perfect line graph.
Look at this table. It gives you the number of students of a particular class who like different seasons. 12 like rainy season, 5 autumn, 10 summer, and 13 winter. Now, can you represent this data in the form of a pictograph? Let me help you. For a pictograph, we first need a picture. Here is a nice picture, a nice smiley. Let's say one such picture represents 2 students. So if I have to represent 1 student, yes, I will need half the picture. Ready? Here is our table. Rainy season, there are 12 students. So how many such pictures do we need? Yes, each picture, 2 students. So we need 6 such smileys. Now move to autumn. Autumn, there are 5 students. So how many such pictures do we need? There you go. 2.5. 2 pictures, that is equivalent to 4 students. And we are talking about 5 students. So we need 1 more student. And as I discussed, that means half a smiley. Summer, 10 students, 5 pictures. Winter, 13 students, so 6 complete pictures for the 12 students, and for the 13th student, half a picture again. You saw that? That's a nice and interesting way of representing data.
Hello and thank you for watching. Today's video is going to be over data and graphing, and it's going to be an introduction on how to graph dot plots. So when we're discussing data and graphing, you need to know that data represents information. It's information that you're looking at in math class. And graphing represents organizing that information. So when you graph information on a dot plot, you're putting information together in an organized way. Now, dot plots use dots or symbols to represent a data set, but you don't always only see dots or symbols. You can see pictures. Dot plots are very similar to picture graphs or pictographs, and dot plots can look many different ways. Let's look at some of the ways you may see a dot plot. So here is a very basic dot plot. As you can see, you have a title, and this dot plot is about the number of books read over summer break by students. And a really important part of dot plots is the key. You have to pay attention to the key. The key is going to give you helpful information so that you're reading the graph correctly. And in this case, I see that the key is telling me that 1 dot means 1 student. So when you look at your dot plots, you need to pay attention to what each dot represents. The other parts of the graph that you really need to pay attention to are the labels. So I see that my books read over summer break is my title. Number of books read at the bottom is a label, and that's telling me that these numbers represent the number of books read. The describing words, pay attention to those, and number lines. Dot plots have number lines. That's a big part of reading a dot plot. So in this case, the number line here starts at 0 and it goes to 9 or more. So if I'm looking to see how many students read one book over the summer, I will look at this column. Each dot represents 1, so when I count the dots, I know that 11 students read one book over the summer. Now, it's important to know on dot plots, if you don't have a key, if there's no key on the dot plot, then you're safe in assuming that every dot means 1. Let's take a look at another dot plot. Here's one where you don't necessarily have dots, but you have circles. And let's look at those labels and describing words. I see number of pets is my title. Number of pets at home are the numbers below. Here's my number line. And so let me see what my key tells me. The key is telling me that every time I see a circle, that represents 4 students. So when I'm looking at this dot plot, I'll count each of these symbols by 4. Let's look at another dot plot. On this one, you see that your dot plot is about student heights. The heights are measured in feet, and you have decimals on this dot plot. You're going to be reading dot plots with decimals. You'll see that this number line starts at 3 and it goes up to 5. And so you see the number of students who were 3 5/10 feet tall were 3. Let's look at one more dot plot on this slide. And this one is also read using fractions. You're going to be reading dot plots that include fractions. And this one, you can see, is counting by halves. So it starts at 0 and it ends at 5, and each increment is counting by halves. Let's look at a few more examples, and remember to keep these things in mind whenever you're looking at dot plots or graphs. Here is a dot plot where it's not dots at all, but it has stars or symbols, and you see your number line, and you have money represented counting by tens at the bottom. On this dot plot, you see that you don't have dots at all, but you actually have pictures, and this one is about coffee consumed, and you have pictures of coffee cups. And here's your number line and the range. So the number of ounces consumed by teachers are 0 to 5 and 6 to 10. So that's how that number line is counting. Another example of a dot plot that you may see is this one. Now this one stands out because the dots are not moving bottom to top or vertically, they're moving left to right or horizontally. So you'll often see dot plots where the dots are moving bottom to top, but you won't always see those. In this case, this one has the dots moving left to right. And it's also missing some information. You're missing information on this dot plot, so you may encounter some of those. And then one more example of dot plots that I'd like for you to see is this one. It's similar to the one I just mentioned. As you can see, your dots are X's, and you have a number line moving up and down, and 0 is moving across this way. So this is about tardies, and my key tells me that every X represents 4 students. So the number of students with 0 tardies are in this row right here. So these are just some examples of dot plots you might encounter.
Hi, this is Rob. Welcome to Math Antics. In this lesson, we're going to learn about 3 important math concepts called the mean, the median, and the mode. Math often deals with data sets, and data sets are often just collections or groups of numbers. These numbers may be the results of scientific measurements, or surveys, or other data collection methods. For example, you might record the ages of each member of your family into a data set. Or you might measure the weight of each of your pets and list them in a data set. Those data sets are fairly small and easy to understand, but you could have much bigger data sets. A really big data set might contain the cost of every item in a store, or the top speed of every land mammal, or the brightness of all the stars in our galaxy. Those data sets would contain a lot of different numbers, and if you had to look at a big data set all at one time, it would be pretty hard to make sense of it or say much about it besides, well, that's a lot of numbers. But that's where mean, median, and mode can really help us out. There are 3 different properties of data sets that can give us useful, easy to understand information about the data set so that we can see the big picture and understand what the data means about the world we live in. That sounds pretty useful, huh? So let's learn what each property really is and find out how to calculate them for any particular data set. Let's start with the mean. You may not have ever heard of something called the mean before, but I'll bet you've heard of the average. If so, then I've got good news. Mean means average. Mean and average are just two different terms for the exact same property of a data set. The mean, or average, is an extremely useful property. To understand what it is, let's look at a simple data set that contains 5 numbers. As a visual aid, let's also represent those numbers with stacks of blocks whose heights correspond to their values. 1, 8, 3, 2, 6. Right now, since each of the 5 numbers is different, the stacks of blocks are all different heights. But what if we rearrange the blocks with the goal of making the stacks the same height? In other words, if each stack could have the exact same amount, what would that amount be? Well, with a bit of trial and error, you'll see that we have enough blocks for each stack to have a total of 4. That means that the mean, or average, for our original data set would be 4. Some of the numbers are greater than 4, and some are less. But if the amounts could all be made the same, they would all become 4. So that's the concept of the mean. It's the value you'd get if you could smooth out or flatten all of the different data values into one consistent value. But is there a way that we could use math to calculate the mean of a data set? After all, it would be very inconvenient if we always had to use stacks of blocks to do it. There's gotta be an easier way. Oh, man. To learn the mathematical procedure for calculating the mean, let's start with blocks again. But this time, instead of using trial and error, let's use a more systematic way to make the stacks all the same height. This way involves a clever combination of addition and division. We know that we want to end up with 5 stacks that all have the same number of blocks, right? So first, let's add up all of the numbers, which is like putting all of the blocks we have into one big stack. Adding up all of the numbers, or counting all the blocks, shows us that we have a total of 20. Next, we divide that number, or stack, into 5 equal parts. Since the stack has a total of 20 blocks, dividing it into 5 equal stacks means that we'll have 4 in each, since 20 divided by 5 equals 4. So that's the math procedure you use to find the mean of a data set. It's just 2 simple steps. First, you add up all the numbers in the set, and then you divide the total you get by how many numbers you added up. The answer you get is the mean of the data set. Let's use that procedure to find the mean age of the members of this fine-looking family here. If we add them all up using a calculator, or by hand if you'd like, the total of the ages is 222 years. But then, we need to divide that total by the number of ages we added, which is 6. 222 divided by 6 is 37. So that's the mean age of all the members in this family. Alright, that's the mean. Now what about the median? The median is the middle of a data set. It's the number that splits the data set into 2 equally sized groups or halves. One half contains members that are greater than or equal to the median, and the other half contains members that are less than or equal to the median. Sometimes finding the median of a data set is easy, and sometimes it's hard. That's because finding the middle value of a data set requires that its members be in order from the least to the greatest, or vice versa. And if the data set has a lot of numbers, it might take a lot of work to put them in the right order, if they aren't already that way. So to make things easier, let's start with a really basic data set that isn't in order. It's pretty easy to see that we can put this data set in order from the least to the greatest value just by switching the 2 and the 1. There, now we have the data set 1, 2, 3, and finding the median or middle of this data set is easy. It's just 2, because the 2 is located exactly in the middle. That almost seems too easy, doesn't it? But don't worry, it gets harder. But before we try a harder problem, I want to point out that sometimes the mean and the median of a data set are the same number, and sometimes they're not. In the case of our simple data set, 1, 2, 3, the median is 2, and the mean is also 2, as you can see if we rearrange the amounts or follow the procedure we learned to calculate the mean. But what about the first data set that we found the mean of? We determined that the mean of this data set is 4, but what about the median? Well, the median is the middle, and since this data set is already in order from least to greatest, it's easy to see that the 3 is located in the middle, since it splits the other members into 2 equal groups. So for this data set, the mean is 4, but the median is 3. So to find the median of a set of numbers, first you need to make sure that all the numbers are in order, and then you can identify the member that's exactly in the middle by making sure there's an equal number of members on either side of it. Okay, so far so good. But some of you may be wondering, what if a data set doesn't have an obvious middle member? All of the sets we've found the median of so far have an odd number of members. But what if a set has an even number of members, like the data set 1, 2, 3, 4? There isn't a member in the middle that splits the set into two equally sized groups. If that's the case, we can actually use what we learned about the mean to help us out. If the data set has an even number of members, then to find the median, we need to take the middle two numbers and calculate the mean or average of those two. By doing that, we're basically figuring out what number would be exactly halfway between the two middle numbers, and that number will be our median. For example, in the set 1, 2, 3, 4, we need to take the middle two numbers, 2 and 3, and find the mean of those numbers. We can do that by adding 2 and 3 and then dividing by 2. 2 plus 3 equals 5, and 5 divided by 2 is 2.5. So the median of the data set is 2.5. Even though the number 2.5 isn't actually a member of the data set, it's the median because it represents the middle of the data set and it splits the members into two equally sized groups. Okay, so now you know the difference between mean and median, but what about the mode of a data set? What in the world does that mean? Well, mode is just a technical word for the value in a data set that occurs most often. In the data sets we've seen so far, there hasn't even been a mode because none of the data values were ever repeated. But what if you had this data set? This set has 6 members, but some of the values are repeated. If we rearrange them, you can see that there's 1 1, 2 2s, and 3 3s. The mode of this data set is the value that occurs most often or most frequently, so that would be 3 since there's 3 3s. Now don't get confused just because the number 3 was repeated 3 times. The mode is the number that's repeated most often, not how many times it was repeated. As I mentioned, if each member in a data set occurs only once, it has no mode. But it's also possible for a data set to have more than one mode. Here's an example of a data set like that. In this set, the number 7 is repeated twice, but so is the number 15. That means they tie for the title of mode. This set has 2 modes, 7 and 15. Okay, so now that you know what the mean, median, and mode of a data set are, let's put all that new information to use in one final real-world example. Suppose there's this guy who makes and sells custom electric guitars. Here's a table showing how many guitars he sold during each month of the year. Let's find the mean, median, and mode of this data set. First, to find the mean, we need to add up the number of guitars sold in each month. You can do the addition by hand or you can use a calculator if you want to. Either way, be careful since that's a lot of numbers to add up and we don't want to make a mistake. The answer I get is 108. So that's the total he sold for the whole year. But to get the mean sold each month, we need to divide that total by the number of months, which is 12. 108 divided by 12 is 9. So the mean, or average, is 9. Next, to find the median of the data set, we're going to have to rearrange the 12 data points in order from smallest to largest so we can figure out what the middle value is. There, that's better. Since there's an even number of members in this set, we can't just choose the middle number. So we're going to have to pick the middle 2 numbers and then find the mean of them. 9 and 10 are in the middle since there's an equal number of data values on either side of them. So we need to take the mean of 9 and 10. That's easy. 9 plus 10 equals 19, and then 19 divided by 2 is 9.5. So the median number of guitars sold is 9.5. That means that in half of the months he sold more than 9.5, and in half of the months he sold less than 9.5. Last of all, let's identify the mode of this data set, if there is one. Well, let's see. There's 2 8s in the data set. Oh, but there's 3 10s. That looks like the most frequent number. So 10 is the mode of this data set. It's the result that occurred most often. All right, so that's the basics of mean, median, and mode. There are 3 really useful properties of data sets, and now you know how to find them. But sometimes the hardest part about mean, median, and mode is just remembering which is which. So remember that mean means average, median is in the middle, and mode starts with MO, which can remind you that it's the number that occurs most often. Remember, to get good at math, you need to do more than just watch videos about it. You need to practice. So be sure to try finding the mean, median, and mode on your own. As always, thanks for watching Math Antics, and I'll see you next time.